So once again, welcome to the second day sessions. So today we are going to listen about descriptive statistics, and our speaker is Professor Balasubramanian Sivaselvan, who is a professor at IIITDM Kanchipuram. To introduce him, he did his bachelor's degree at Bharatiyar University and master's at IIT Madras and PhD at NIT Trichy. So he is a recipient of several honors and awards. Some of them are AICTE fellowship. He is a recipient of All India Council for Technical Education's Early Faculty Induction Program Fellowship, so on. So he has several years of work experience. Also, he is an author of several reputed journal and conference papers. So now the platform is for you, sir, Professor Balasubramanian.
Thank you, sir. So, good evening to all audience who are as part of this AICTE's or ATAL's workshop scheme. The first place, good evening to all. And first place, I would like to thank Professor Vishwanath for this opportunity to be part of this workshop as a resource person. Okay, so, right. So, let me share my screen. I hope the screen is visible.
Yes, sir. Yes, sir.
Okay. Is this also visible? Because
yeah, this is full screen.
Yeah, okay, sir. So in case people want me to stop in between, right, or you have some clarification, I think at least I am okay with people unmuting and talking in between. Okay, right? So because the chat screen is not visible for me in full screen mode, so people can have the liberty of even unmuting and stopping me in between the lecture as well, or in between the session.
Yes, sir. Yeah.
Thank you, sir. So I think as Professor put it, right, so the objective of the session is possibly to touch upon the power of descriptive analytics, as they put, right? So, or how does it help? So, eventually, descriptive analytics will help us within the major task of data summarization, right? You can use this also as an introduction to data analytics, okay, right? So, I think just to kickstart some basic terminologies which you possibly should have heard, but I think there is too much of data words going around, or too many jargons, which possibly people tend to mix one over the other. Okay, right? So, first place, I think the need for data analytics, all that has come up only because of the extensive automation that the society or people have subjected to, right? So the objective of any automation exercise, automation is where you want some software or a system to do a monotonous task, right? So, but the eventual objective of any automation exercise is basically to convert data into information, right? I think that possibly, I think most computer science audience, EC audience, right, should have heard this at some point or the other, right? So any automation you do is basically to convert raw data into information, right? And this conversion per se, right, is what constitutes the core courses of your CSE curriculum, right? So the various courses you read, and possibly to some extent even an EC, right? The whole objective is what all processings I have to do eventually so that data becomes information. Okay? So that's the way I see the entire CSE curriculum as. Okay, so and the classical college differentiation that they give for data information, right? Data is raw in nature or raw input generated in real life, like marks scored by a student, right? All such stuff which is raw in nature as it comes in real life is viewed as data, but something which is processed the data is what is referred as information, right? Similar, but keeping your mark example itself is mind, right? The mark can be viewed as raw. There is a grade that you assign because you do some processing like an if-else, right? If the mark is greater than or equal to 85, give an S grade or best grade, right? So I think that is what we mean by processing. So process data is what is classically referred as information, right? And I think this slide may look sort of very basic, trivial, but I think people are living with this assumption that It is only Python that can do data analytics. Deep learning is the mother and father of everything in data analytics, right? Long, long ago, right? Even before all this Python stuff came, right? Or it started out with MATLAB's Octave package or something, right? There was some good statistical processing capability with some of the earlier tools as well, right? I think one example which I pitch, right, is possibly the power of Excel over C, right? I think the traditional years, right, C was the preferred language for automation, right? So your front ends, you don't have this notion of a front end, a back end, right? The entire automation exercise, the programming used to happen in C, right? But then the possible limitation of doing data processing in C is because I think you don't have dedicated data management capabilities, right? I hope the audience can interact, right? So, what is a typical programming construct in C which you will use to store data? I think the audience can interact so that it does not become monotonous. What programming construct or what syntax in C language will you use to store data? Permanent storage.
So normally we use file management
Excellent,
for.
right? So typically files are the way out if you want permanent storage. If it's wallet temporary storage, you go in for structures or arrays, right? But what's why I'm highlighting it? C also had some possibilities or support to do data processing, but then why was there a dedicated area of a DBMS coming up, right? Database management systems such as MySQL, Oracle, all that stuff, right? Access, MS Access, right? They didn't have powerful data management capabilities in C, right? I think typically, let's say you are maintaining, I'll quickly sum it up. For an institute, if you want to maintain the database, right? So you will have a faculty file, a student file, a hostel file, and one student data can exist in multiple files, right? The account section may track his fees, the academic section may track his grades, right? And let's say one student leaves the institute. The problem with C language for such data management is, right, it has to be deleted uniformly, right? So that this is what in DBMS circles they classically call it as the spurious deposit. Not C data can creep in. To sum it up in one line, right? C did not have dedicated data management capabilities. So that is where they came up with SQL, and then MySQL is the open source version, right? Typically on Linux. But I think people should know by now, at least MySQL, the entire source code of MySQL is written in C language, right? So eventually they are resorting to files, file pointers, everything, but they are giving you dedicated querying such as select command or select query, right? Nested querying, all the support was there, right? This is just to quickly trace the history, right? So started out with file processing setup in C, then moved on to database management, dedicated data management tools such as MySQL, right, and many more other these days, right? You can achieve, that's what I said, right? So you can achieve the same thing as you do in DBMS, but then it's tedious, data integrity is not guaranteed, right? And eventually a DBMS setup, you can also view it as nothing but an information retrieval, right? Retrieval is to say, right, I have stored data available. What is the possible information I can get out of a DBMS? Let's say student database you are storing, right, or a student database setup it is, the grades of the student, the marks of the student are stored, right? Who has scored the highest mark in the semester, list of all students who have scored above 60%, let's say for a scholarship task, right? So these are possible trivial information, right? This is what a DBMS can do, right? What does a red last bullet explicitly show, right? So a DBMS could only give back as output information which is in some way explicitly stored in the data. What do I mean by that? A DBMS tool or a DBMS setup cannot extract or cannot retrieve hidden information. I hope people are getting the fact, right? So something which is not stored explicitly in the data, that's not possible to be given as outputs from a DBMS setup. And that is where this craze for data analytics started out, right? People were interested in, yes, I have enough tools which can give me out existing information in varied forms, aggregated forms, like average salary, highest salary, standard deviation, all that stuff is fine. But can I look at some relationships between data items? Right? I think that is where you have this concept of descriptive analytics, predictive analytics. Predictive analytics is typically what is application of ML or AI over your database setup. In fact, you can view your data mining. That's what I said, too many terms, data science. There are subtle differences. I think I'll not go into that because then I'll be deviating from the focus of my session. Okay, right? So eventually, DBMS, yes, it could give out as output what is already there, but what is not there, which is explicitly or implicitly hidden in the database, how do I discover that? That is where statistics and ML came into play. I think some of the terminologies which you can hear, right? So what is called as descriptive, there are three types if you want to sum it up. Descriptive analytics, predictive analytics, and you also see these names of big data analytics, right? Already a DBMS is big enough. So what is big about it? Right? I think these days at least, right, data does not get accumulated at one point, right? I think with the power of high storage capabilities, right, the cloud storage, all that stuff. So I need to have efficient storage mechanisms which can do online data analytics also, right? So I think the bullet C, you can possibly equate it as big data analytics concepts, which actually focus on efficient storage and indexing mechanisms to support analytics, right? The first two, right, A and B, right, the bullets A and B, right? Descriptive analytics, predictive analytics, a broad categorization if you want to give, right? So descriptive analytics is about, so what are the analysis and where did the word analytics come from? Basically started out with analysis, right? And then they wanted to make it a technical with respect to the domains of statistics, ML, etc., right? So an analysis approach which will help me to describe the database I have or describe the data I have for better insights about the data, right? So can the user get key insights from the data without ever getting into ML or AI, right? So I think just to pitch the difference right at the start, there is a strong misconception that if it is analytics, it has to be predictive analytics. Definitely not. Predictive analytics is about, or you can view predictive analytics as this way, application of ML concepts or applied ML over your database setup is what is typically referred as predictive analytics. Right? Descriptive analytics, which is even more basic or which possibly has been there for ages, right, is about using the power of statistics and other math tools available, which can help me to describe, another word you can use, to summarize the data in a better fashion for the user to understand a key or to gain key insights from the data. Okay, I hope people are able to differentiate between this descriptive and predictive words. And I think at least I teach a course on this. My focus is to say, or the students, the general advice we give, right? Do not start with this because Python has made it that crazy to straight away do classification. It's just a question of a function call or a library usage. But then people don't understand what they are actually predicting, right? So descriptive analytics actually helps you to understand the current data I have better, and then you try relating predictive analytics, which all parts of the database, which attributes are important in the database for me to track for relationships among them. So that will be a good flow. Ideally, what I suggest is you see it as a flow chart, right? It's better to do a descriptive analytics strategy first and then possibly explore data classification, data clustering, and many other terms. I think I saw some support vector machines, all that stuff, right? I hope people are with me, right? So descriptive analytics, you can see it as a first step of any analytics strategy to better understand the current data I have. And I don't want to give a number, but 50 to 60% of the key answers you're looking for can possibly get answered even within a descriptive analytics approach, right? And I think modern day is full of terms. A more detailed classification on the internet, right? You may find these four as well, right? Something descriptive we already seen. Diagnostic is typically in the medical domain, right? So can you come up with, if you want English questions equivalent of it, right? Descriptive you can possibly look at as what parts of the data are important for me to focus on. That's what I said, which attribute is important for me to track further. Okay. So what part of the data is critical, that's answered by descriptive analytics. Diagnostic analytics, why for the earlier question you had, right? So what are the reasons for which it becomes important? Typically more interested in the medical domain, as I said, right? Because I think that is where diagnosis it comes from. Okay. Predictive, given the data I have, what is likely to occur in future? Okay. Right. I think it's a layman question to ask these days. Can people give some good examples of predictive analytics which you use in day-to-day applications? Can somebody give a good example for a predictive analytics from some of the websites which you visit? Now, I know it's 7 o'clock. It's 7 o'clock for both sides. Right? Because I'm looking at a blank screen alone with not even the photos available, right? So if people ping back, it will be helpful, right? Just some name, some application or website where you have seen predictive analytics at play. Come on here.
Some stock market kind of stuff where the prices are predicted.
Excellent, correct, right? The prices are predicted, but I think just to give a more some websites which you frequently visit, like your Amazon, your Flipkart, right? People who bought this also bought this, right? But those are predictions, right? What are they trying to do? I think this is the joke I share, right? I don't know how many of you are aware. Amazon actually started out selling books. Okay, that's the way we remember. But these days, it ends up making people buy everything else other than what they wanted to buy. Right? So I think that's the power of, can I look at, and how are they doing it? How do they say that if you buy A and B item, you are likely, you may be interested in C or D? On what basis do they say that?
They may be trying to correlate different items
Excellent, right?
and
So,
then try to.
correct, spot on, right? Look at the past purchasing pattern of this user or the various users I have, right? I hope people are with me, right? So what is likely to occur in future is a question answered by predictive. Prescriptive typically comes from medical domain again. Once you have predicted what all should be done typically to avoid such scenarios, mainly the mechanical industry, the aircraft industry, or what we call a safety critical systems. Right? If you are predicting the system is going to get into a dangerous state, if you allow the current sequence of operations, so what should be done for me to avoid that state comes from the medical terminology of prescription. Okay, right? So I think what we are interested in is typically the first bullet of descriptive analytics. Good, right? I think as I started out with, so I think these terms which you keep hearing, right? So data science is the modern jargon that they keep using, but I think all don't mean the same. Okay, right? So typically, descriptive analytics is just relating the power of statistics alone, right? I think I said you don't even have to have Python. Python you can do some amount of descriptive analytics as well, fine. But Excel or what is some Linux equivalent of it called as Office Libre, right? Open Office Libre, right? Or present Excel Compute or something they call, right? So those minimum data management tools itself, they have good amount of statistical support, right? Which can help you in analyzing the data you have, right? And why should you do, I think the bottom bullets, right? Data mining is also, I think somebody used the word knowledge and, right? See, I think information is typically used in a DBMS context, but information that is extracted out in an applied ML context in an analytics setup is typically referred as knowledge. Okay, I think the difference is knowledge is something which is implicitly hidden, right? And the earlier days, extracting such hidden knowledge we used to refer as data mining. And in the current day, they do make some difference between data science and data mining towards the end. If somebody has that, then I'll be missing out on my summarization portion. But each term is different actually. Right? Data science, data mining, data analytics, descriptive analytics. Right? So, but why should I think one of the bullets that machine learning has really gone too deep these days, right? Deep learning is right at the bottom of the curve, right? why is ML or why is data science important, right? The objective of any ML exercise or you apply ML, why should I do data analytics? Can I use the current data I have to answer questions either based on the current setup or futuristic scenarios in some of the four terminologies which you saw, right? So the objective of an ML exercise as part of prediction, right, would be to learn a model from the data I have to answer futuristic questions. That is when it becomes, when you describe the current setup, it is descriptive analytics. Then you try to answer futuristic questions, then it becomes predictive analytics. Okay, right? So you are rushing through predictive analytics. I think you will have possibly dedicated sessions, the other speakers there. Okay, so okay, I think I will share this entire slide with the speaker, right? So these are possibly some of the good references which I have seen over the years, right? And I think at least one person whom I wish to highlight, right? This all are there. Rajiv Motwani, right? I don't know how many of you heard about him, right? So he was the advisor of the Google founders, Sergey Brin and Ericsson, I think, right? So he was in, I think, BTech IIT Kharagpur or Kanpur alumnus, right? Unfortunately, no more, right? I think he has made phenomenal contributions in data mining. Many other are there, some of whom are listed, but I don't want to go through this, listing it out. You can possibly pick it up. Hadoop and PySpark may not be relevant for this audience if you are interested in big data analytics and all. Good. Okay, just bear with me for a while. 4 to 5 slides of my handwriting, right? Because this is out of earlier handwritten notes. But eventually we will go back to summarization via PPTs. Okay, right. So I think what we referred just now as descriptive statistics, right, or descriptive analytics is nothing but, if you have to formally define them, right, application of the power of statistics or statistical techniques over the current data I have to better describe it, right? So how can I represent the data, right, and maybe use the techniques in statistics to better represent the data, right? I think all this has been brought about, right? It's a summarized view of the data to gain critical insights, right? But as a statistical person, right, I don't know how many are exposed to mathematical bent or statistical bent audience. This, right? The moment you are moving deeper into statistics, right, or a statistical approach, or as we say, descriptive analytics, I think these two terms make a lot of difference there, right? What is referred as sample data and population data, right? Some occasions, right, or some application scenarios, you may have the entire population data available, right? Just to give you examples, I think the Amazon prediction, the Flipkart prediction setup and all, right? So they are basically building models based on the past data they have gathered, right? So that is the population data, right? But there are, let's say I'm interested in computing what is the average height of students who may join a BTech program in India, let's say, right? I think it can be central CFTA exams or state exams, right? Average height of a student, right? So which means you possibly have to look at, for you to do a proper statistical exercise. Somebody can answer this. I should look at all possible dash in the country. I'm interested in average height of a student who joins a BTech program in India. To do a proper statistical exercise or statistically sound exercise, I should work with data coming at least from all states in the country, right? And then equal representation of boy samples and girl samples, right? I hope people are getting it right. Why am I getting in there? Such tasks, right? This is just one example again. You may face in real life several applications where you may not be able to work with the actual data or the complete population data. You may be only able to work with samples of them. Right? So I think that is where we use the word sample, right? A representative of the actual population. A good exercise should be covering exhaustive samples, right? Why am at least in statistics, right? There is a difference whether are you working with a sample data or a population data. That is where most of the ML exercises typically work with population data, at least as a descriptive focused person, right? You should be able to differentiate the fact that not always I will have the liberty of entire data available. I may have to work with samples as well and then make generic inferences, test of hypothesis. And I think I did see in the schedule some test of hypothesis sessions, right? So that's basically to make inferences based on the sample data or a short representation of the actual population. Okay, right? So what's the basic power of statistics which I'm trying to tap, right? There are excellent representation mechanisms in statistics, right? Or even visual, I think some parts, they also view this as visualization techniques or data visualization as they call, right? Forget the formulas, there are good amount of visualization tools, or what was our typical +2 or 10th graph concepts, whatever you studied, right? pie charts, bar graphs, histograms, and I'm not going to get into the basics of them, but at least some of them which you may not have heard, just to pitch the importance of them, right? So box plot, line plot, many are there. This is just an illustrative list of some of the visualization mechanisms. If you put them in one of these formats, you possibly can answer some critical information about the data without even having to bother about prediction, and all comes later. That's the another point I wish to make. Right? So eventually each of them, right, whatever visualization tool it is, or visualization charts as you call it, eventually they will be based on some statistical measure. Scatter plot, many more are there, density plot, rect plot, right? Some of them we'll see, but the exhaustive treatment may not be possible in this session. And I hope people are clear with the objective, right? So how do I use the visualization support? How do I use the statistical concepts? Like I think somebody said correlation word, right? Correlation, variance. How can each of the various measures in statistics be effectively used for me to capture key insights from the data I have? Are things clear? Can I proceed? No answer means assume yes. Fine. Okay, right? Okay, when will you switch to your slides? Slowly. Okay, right, quick. So this approach, this technique of what I call as descriptive analytics, it is also referred as exploratory data analytics in industry circles, EDA, right? So applying statistics to understand the data better is referred as exploring the data, current data I have, right? Or you whatever. Okay, just I think some of them may be faculty, right? So let's say you're doing a grading exercise. What is the key statistical measure you are interested in, whether the class did reasonably well or not? I have conducted a course for 100 students. Exams are over. Did the class do reasonably well in the course? What is that statistical measure you are interested in?
Maybe some, midterm examination results or their attendance or their practical grades kind of stuff.
Correct. To be the basic statistics, average, right? Class average as they call, right? So out of 100, something around 40 to 50, right? It's a reasonable, but I think in online period we will see the average is shoot up to 70, 75, fine, right? So average performance of the, what am I keen on, right? Even that simple measure of how did the class do on the whole well. So average is one statistical measure which can indicate, but average is not always successful. Okay, right? Why shortly, possibly somewhere it will get highlighted. Okay. I hope people are getting it right. So you have 100 students marks, but eventually for the institute, if the students find the course interesting or not, it is class average, which could be an indicator, which is actually nothing but a data about the data. In DBMS circles, we call this as metadata. I hope people are getting it. So average, not a too big a metadata, but it is still giving you some insight about the data, right? Just to give you why averages are bad, right? So let's say in a class of 10 people, 9 people have scored marks in the range of 40 to 45 or 40 to 50, let's say, and one student scores 100, right? So approximately what do you expect the average, or how will the average get drastically affected? I think sum of all is 40 around.
It's
140.
50, about 50.
It should say, I think the average without the last student's mark should be hovering anywhere around 45 to 50, but suddenly it can jump to a 70 approximately, right? We calculate later. So what I'm keen on is average is not always a good indicator. That is where, right? Median is what is the issue here? Average is not good to noise as they call, right? That 100 or whatever last mark I gave, right? You can, I think statistically, whichever is deviant from the normal pattern of data you see, right? That's what is called as an outlier or noisy data, right? So averages are not good at handling outliers. That is where, right, the next statistical measure of median is powerful, right? Sort the data n by 2 or n by 2 plus 1 term, whether it's odd or even sequence, right? Even number of data you have. I hope people are getting it, right? So we started out with the mean. Average is what statistically referred as mean. Some places it is helpful, where that's not helpful. Median may be a good metadata about the data I have. And okay, these Amazon, all these predictions which happen, What should be the basis on which they predict? Do they predict it just when one customer buys, or what is your guess?
No, like the history of past many
Excellent, right?
readings.
Out of 100 past transactions, was some frequent number, did 20 people or 30 people, did they see this purchasing pattern frequently or not? Okay, just, I hope my double quotes finger is visible there, right? Now, why are you bringing this? That frequently what you use in ML circles and all, right? As frequent pattern mining. I think the base of it comes from that concept of mode in statistics. The most frequently occurring element in the data set I have is called as mode, right? I hope people are getting the. I'm not saying descriptive analytics is equal to predictive analytics. That's not my objective at all. But then people should come out of this craze as well that I'll start out with predictive analytics. That's a wrong way to do analytics. First place, understand the data currently better. See this as a flow chart. First step should be descriptive analytics. Then maybe go and play with whatever power of Python you get for predictive. Okay. I think tweet data analytics is just an example I give. Right. So what are, as a descriptive analytics person, right, I think even when you learn to C programming, right, or even when you learn DBMS or MySQL, first place, the first lecture is about what are the different types of data you handle, right? In C, maybe you call it integer, float, all that stuff. So what are the possible data that a descriptive analyst has to handle? So data in real life can be either in number form, right, or numeric as we call, right, or it can be textual, names of person, addresses, right? First name, last name. So data can be either numbers or numeric. Textual, right? As I said, typically textual here means strings. Symbolic is characters, right? This is the descriptive analytics view of a data type I can handle, right? Numeric, textual, or I hope handwriting is legible. Fine. Symbolic is nothing but characters, gender of a person, grade scored by a student, A grade is grade, single character. Okay, so that's typically referred as symbolic. Another view in the descriptive community is data can either be qualitative or quantitative. Right? Quantitative is what we typically call as numeric, right? It can be either integer or floating point stuff. Floating point will refer it as different in the sense the terminology differs. Qualitative is you don't have this amount or quantity of information available, but it gives. Okay, give us an example. I think in the COVID period, right? In area, it is in. They had some color codes for COVID zones, COVID impacted zones, right? Red, orange, green. Let's say, for example, right? So red, green, and orange. Those are categorical. Okay, so I think now you have to define what does a categorical attribute mean. See, I think numeric, right? Integers, it can, depending on the domain, whether if it is age, it has to take some value between 20 to 50 based on the application, all that stuff. Depending on the domain, right? The values can either be finite or infinite, right? Qualitative or categorical attributes, as we call, typically such attributes or such data types carry values from a well-defined set. Right? For example, the color codes for COVID, I said, right? It can be either only red for dangerous state or high impact, orange for a moderate state, and green for a really safe state, right? So, if an attribute takes values from a well-defined enumeratable set, enumeration, the word is there, right? So then it is referred as a categorical attribute, and in that we have this differentiation or focus on. My categorical attributes can either be nominal or ordinal. Ordinal is when, I think this COVID example I gave, there is some ordering in it. Right? Okay, grades, how do you view? What do I mean by order? There is some, if I say red, right? Red is of highest priority or dangerous priority, red, green is of safest or bottom level priority. Such data types where there is some inherent ordering present in them, then that's called ordinal. Ordering is there. Some sequencing is possible. Nominal, there is no ordering possible. Right? So it is just the values that are important. There is no ordering in them. Then you call it I think gender of students in the class. Right? Typically, you are not allowed to differentiate people on gender. Right? So gender you can view it as a nominal one. Right? Many more are there. Good. Right? So I think so. One example or categorical is equal to qualitative. Right? The bottom. I am presuming people can differentiate this notion of a set and a sequence, right? Well, what is the difference between a set and a sequence? collection of elements is what you call as a set. This is the benefit of online, sir. We don't have to answer. See, set is typically you don't have an ordering depend in it, duplicates not there. There is a sequence, right? There is an inherent ordering present in it. Duplicates can be possible. 122, 112, or 121. Right? I think ML we call sequence pattern mining. Okay, right? So I think at least you should know about what are the possible types of data we are having. We thought we will see some plots. It's coming quickly, right? Get out of this handwriting quickly, will do, right? So numeric, right? So what are the types of, or what are the base level types we have? Your numeric data types can either be discrete or continuous, right? Well-defined countable values within an interval, right? So let's say your mark, right? Let's say I'm not giving any floating point mark. To specific to the application, you have to look at, right? So there is no half or quarter possible, right? Not beyond that also, right? So you can, let's say between 50, minimum is to pass is 50, maximum is 100, right? So if you can count the number of values that can possibly occur within an interval, then that's discrete, right? Numeric, or maybe the continuous numeric, I mean, right? Heights of, I think that example I gave, right? Height of a BTech student, right? Height of people, right? So let's say the minimum height is 20, another extreme, or 20 to height is to inches, it is too much to start. Let's say 5 to 10, right? Or 4 inches to 10 inches. What is or what's the differentiation between a discrete attribute there? Heights of people, typically what you call as floating point in C, but mark, you can possibly view it as discrete. You don't go beyond 2.5, maybe one step further, 2.25 as a quarter, right? But height, of people, see, it can be 7.5, some point. 7.5 is too high, okay, 5.5, 5.75, or what we call the number of digits to the right of the decimal is precision, right? But at least that's specific to the application, right? So you can't come up with a finite set of values, right, with respect to a continuous numerous or a continuous numeric attribute. Are these differences clear or not?
Yes, sir.
Normally what I do, I go to my GMT session to see if people are alive. Okay.
Yes, sir.
Yeah, I'm seeing the same 16. Okay, no issues, fine. Okay, I'm back here. Okay, so this is the problem. Okay, done. Right, I think this slide should be about what I summarized now, right? So nominal examples, right? Ordinal ordering is there, color code for pollution, right? I think this slide I'll skip, you can look at it later. Roll up, drill down and all, right? So what's the power of descriptive analytics, right? I think somebody used the word stock market, right? That's an excellent example for big data we typically give, right? See, you may have, what's a big thing or critical thing about stock market data? The fluctuations in the stock market. Are you interested month-wise or year-wise, or what's the level of atomicity you are interested in tracking stock market data? Okay, at least people who do trading, right? They can answer. Do you track it weekly ones or monthly ones or 6 months ones or half yearly or yearly? Typically, you do it every hour or even by the second of it, right? What are you meaning it, right? I think that's a real scope for big data because the same stock's price on a specific working day starting at 10 o'clock, 10:05, maybe 5-minute interval, let's say, right? So that is where you can have plenty of data getting generated online and big data scopes come. Why am I relating here in descriptive analytics? The levels of granularity, what level of atomicity is what I mean by granularity, right? See, as far as the company is concerned, or the stock market, what is that body called this? The stock exchange people, right? So people who regulate all these markets, right? They are interested in how is the stock doing overall, typically on a quarterly basis, right? So once in 3 months, right? So at a stock market analyst level, the level of granularity I need is 3 months once, how is the stock performing? But for the company person, he may be interested in, are we getting it or not? The same data, how is it performing at a Quarterly is 3 months, right? Correct. 3 months once, 6 months once, yearly once, monthly once, weekly one. So the level of granularity, I think that's the power of descriptive analytics. You have excellent tools available. You actually move up the hierarchy, starting from day wise to yearly once. That's called as rolling up, because you're rolling it up to the interpreting the data at the highest level of abstraction or granularity. The bottommost level, it is called as drill it down, right, to a bottom detailed extent. Okay. I think I should have another 15-20 minutes. Quickly, I'll go through. Okay. Okay. Right. The dates and all is typically my handwritten notes. Fine. So, what are you actually interested in? I think some of them have already brought about, right? So, can I use what we call as mean median mode, right? It's statistically referred as measures of central tendency. So, these are measures, many more are there, right, which will indicate whether the data you have is actually tending towards the centrality of it, right? So, is it following average, median part or not, right? Or the other way around, the exact opposite of it, is the data I have, is it dispersing or deviating from the centrality aspect, what is referred as measures of dispersion, right? Standard deviation, variance. Now, I think this session maybe will not be about the formulas. We'll quickly move to some plots, and typically box plot, which is an excellent indicator which tracks both your centrality as well as dispersion. Okay, right? That's what I've highlighted there. Box plot, histogram helps in identifying the modality of the data, right? So what distributions it follows, right? Some of the other plots, stem and leaf, it is called, right? I think this is all typical school stuff, but you'll be surprised to see so many plots are there which can help you to understand the data much more better than even before you start mining them. Okay. Okay, because I just wanted to come out of this handwriting. Are things fine so far? Okay, momentarily coming to the meet so that any issues you have, you can put it in the chat. What have we done so far? We only defined what is descriptive analytics, what's objective of it, and what are the possible data you may, or types of data which you may encounter, and some of the core concepts, core fundamentals in statistics, which actually these plots play with and give you a critical insight, right? So I hope I can move on to the plots, right? I'm on the G Meet. You can ping me in there. So if you're not comfortable talking, texting is much easier in this generation. Text. See, even the network ping command, right? Ping, I know people are used to ping command, right? Ping command is a command in network which says people are alive. The packet sent from one end is reaching the other end. Okay, right? So some return packet has to come. Okay, some faces are smiling, which means people are active. Good. Okay, moving on. Right, so I think don't teach us how to do pie charts and all. I know people are experts in all this, right? We quickly sum up, right? Pie charts, right? Typically, I've recommended. I think the quick statistician view. I think what is this pie about? Or around 4 to 5 colors I have based on their dominance, right? Allocate portions in a circular wheel, right? View it as a 360-degree sector available. And what does it help me in convey the most dominant, right? Typically, when do we use pie charts, at least from an academic setup, right? The percentage of students are in the institute, right? Boys to girls, right? And then maybe different. Okay, can I go in for pie chart to represent student percentages from various states? No, I'm not teaching what is a pie chart. I think that's a typical schoolroom stuff. See, pi is typically recommended when the data you want to analyze or you're looking at is anywhere between 5 to 7, not more than, because I think that is when the sector size, which will help you to come to a conclusion that this is the most dominant, or these are possibly 2-3 major sets available, right? So typically the number of programs that an institute offers, right? BTech, MTech, PhD. So such data is better to analyze using pie chart. Number of states 25, you can draw it using a pie. I know Microsoft Excel is excellent in drawing pies for any number of size, but the sector sizes will become so small that there is no key statistical insight that you can get out of it, right? I am assuming that this audience will not expect me to teach how to draw a pie, right? So these are various, I think somewhere in the slide it will be there. Sum up all, relative proportion, and then these are again some variants available in Excel, I guess, right? So exploded pie chart just to signify, right, one sector of it, right? And then pi of a pie they call, right? So at least in one sector, that's most dominating one, right? So what are the other classifications? That more interpretations within the pie, right? So that is where a bar can help, and a 3D setup is as well there. Okay, right? So this is the, I am not going to get into it, but you can, this is the way or the calculations to arrive at the percentages for the various colors you had, right? So some of the frequency of all, the cumulative frequency sum is 1175, and blue is occurring 112 times. So blue's dominance is 10% approximately, like that, right? On a percentage, or you want it in a degree notation, right? You're going to, typically it is percentages, right? Good. But what should be new? New or few, right? When should you, I think that's the fundamental question which a descriptive analyst should answer, right? When should I use which plot, and which plots are good for, or what are the merits and demerits of a plot, right? So if you summarize a large data into visual form where you want to gather about dominance, working with a relatively small number of categorical type data, right? B Tech, M Tech, and all, right? The number of programs, right? Demography in the campus, girls to boys, right? So it's a simple and easy to understand picture it gives, right? But what is the problem with pi? As I said, when the number of data increases, it's too difficult to track the dominance. But the most important thing, pi can be manipulated the way the application side wants, right? So I think you are computing. I'm not saying literal word to put it is seating. I know that yes, it can get recorded possibly, right? But not necessarily what is shown in the pi. Now, what's the problem? The pi does not reflect the actual values, right? It's only a percentage of it, right? And that can be actually misleading, right? Because in a small, let's say an institute which has 10,000 students, another institute which has only 50 students in the campus, the percentages there could be a misleading aspect, right? Is a class, I should not call it as a class. Are people appreciating? I think that's the role of a data analyst, right? So which plot should I go in for? And what can I believe blindly, and what should I not believe blindly just based on the percentage I get, but much more deeper into it. Okay. I think typically this is for 1.5 hour sessions content, but quickly I'll go through. Okay, right? So I think, so pi you saw one, right? So I think this is again example for a histogram for a continuous data setup, right? So average waiting time of customer in the queue, right? X-axis is the range, y-axis is the frequency. So what does this help you in giving, right? The maximum, right? And how many peaks are possible, right? I think histograms help in identifying the peaks in the data, right? That's what we call as modality. There is only one mode, unimodal. Bimodal means two modes in the data. Two peaks are there, right? Multimodal, multiple peaks are there. See, later you can use which distribution it is. Just to recall, typically in real life, things are said to be following a normal, what comes in it? It's the regular pattern that is being followed is typically the normal distribution in statistics, right? So that normal curve, right, or the bell-shaped curve, typically if you draw an histogram and connect the midpoints of each of these bars, hope my pointer is visible, right? So that will help you to quickly take a call whether the data is following the normal distribution or not, or is it skewed, right? Now, I'm not saying this is the complete details of the statistical measures possible from normal distribution. Many other types are there, right? Weibull distribution, many more are there, exponential and all. But these plots help you to quickly make some conclusions whether the data is following the normal distribution or is it deviating from the normal distribution, right? I think these are what are the components of. I think no, you are skipping a lot of slides. I hope that's not the impression I want to convey. So what does x-axis and y-axis of histogram convey, right? Typically, x-axis is the range or the scale of values to which you are making the measurements. Y-axis is the frequency, right? So the taller the buildings you have, right? So that's possibly indicating the most frequently occurring. So frequency aspect is quickly gettable from histograms and bar graphs when you do it for discrete data. It's there, right? So it depicts, that's what I mean, the real power of histograms and bar graphs, right? The median of the data, the distribution of the data, and the other, the really small buildings compared to the taller buildings. Buildings, what do I mean? These are buildings for me, right? In this case, there are no really tall buildings, but let's say some are really tall, right? So then the smaller ones, you can view them as outliers, need not focus too much on that data I have. Okay, right? I think these are variants of histogram, right? So that's what I meant, right? This is, you connect all these midpoints and draw a curve, right? So this is typically something the normal bell-shaped curve. Again, commenting on the modality of the data, right? Two peaks are there, right? So it's multimodal, or it's all right skewed, right? This is, let's say, class average. Everybody is more closer to the higher mark, or more 70s and 80s are there, or left skewed. Now, this is not about showing the color of the bill, right? I think just plotting the data you have in one of these forms, and to the extent I know, I'm not sure about how much Excel supports all these types of histograms, but Python does have dedicated packages where you can draw each of these types of histograms, whether the data is left skewed or right skewed, right? A visual mechanism which can make you quickly narrow down, I think, too much on the higher side, lower side, how many modes are there, etc. Then you can go and look into the details of the distribution. Okay, I think so. I think that's the towards the end of each plot, right? I'll basically be summing up the positives and negative of it. Okay, right? Frequency is visible, visualize the distribution is possible, right? Again, it's what we call as a lossy plot, right? Exact data values may not be reconstructible, right? And the problem with histograms or bar graphs is you can't compare two data sets. What do I mean? Let's say two different institutes, right? AAIT Kanchipuram versus AAIT. I should not make it a competition just for the sake of or the fun of it. Right? AAIT City versus AAIT Kanchipuram. How were students faring in their college exams, right? So such sort of comparative analysis, if you want to do, it's very difficult to do using a histogram. Histogram typically meant with continuous, but you can draw bar graphs for discrete as well. Okay. Sir, if I think if I'm too much violating the time, you can stop me. That liberty is there with the coordinator. But at least sir, am I allowed to go for another 10 minutes at least?
Sir, maybe 5 minutes.
Okay, sir, 5 minutes. Yeah. Okay, then I'll wind up quickly, right? So I think you have seen histograms, pie charts, right? Dot plot is another. I think this is, right? So this is possibly some 7 courses, let's say, students are taking, right? So this is similar to a frequency plot. It's a frequency plot, but then what's the beauty about it? You can still comment out who is the most dominant, modes are, or your modality of the data is commentable. But the great thing, the exact data points are also tracked here, right? I think there is the loss that you encountered with your histograms, right? That is avoided here, okay, right? So I think, so it's the stem and leaf plot, right? Quickly, I'll tell you what does the stem and leaf plot mean. So it's this example is, right, the stem is what is towards the left of the decimal, the leaf is actually to the right of the decimal. Okay, so 5.8 is what I'm representing as 5 in 8, right? So now what does this similarly you can do for other? This is very important for the stem and leaf plot, what we call as the legend of the plot. What does this help me in? You just tilt this view and see, you can quickly conclude that many more marks are there around 70, 73, 74, 76, 77. Correct, right? I think view this way, right? This is almost, you tilt it this way, it's almost like your histogram, the exact data are there, so it's not a lossy plot. So, okay, in the interest of time, I'll pass on the full slide. There are ways, and I think you can represent even, it's how do you define the legend, okay? So in some places, if you want 10.4, right? So then it is 10 and 4 this way. And this is what I meant by 2 different classes. How was their performance? This is what was not possible in your histogram is now possible very easily here, right? Same course, not different courses, based on the class sizes, how did they perform? I can do a visual comparison quickly. Right? Okay, when I share this slide, you can possibly solve this exercise. Right? I think this is the power of some really detailed questions can be answered just by looking at the plot. Okay. What's the maximum mark in section 1?
9.
Read it along.
95.
95, that's it, right? And the highest number of marks in the specific range, I think 70s are more in section 1, maybe 60s are more in section 2. Right? So I think I'm just rushing through. I know I typically do it over 2-3 classes, fine. Good, maybe you can look at it later. Okay, right? So this is scatter plot. You all know this, you have seen it. That will help you to comment whether it is positively correlated or negative correlated. Okay. As x-axis increases, y-axis also increases, positively correlated. As x-axis increases, y-axis decreases, then it is negatively correlated. Totally scattered around, then there is no correlation at all. I think that's the power of plots. Without getting into the formula for correlation, all that stuff do later. Just plotting them and seeing can help you understand better. Okay, I'm skipping them. Right. Again, this is a one full classroom lecture, but I'll just wind up saying box plot is a really powerful plot. So far, you have seen more about centrality, right? Box plot is one statistical power which helps you to understand both the centrality as well as about the dispersion or deviation. Okay, typically it works as assuming the data can be fit into 4 quartiles. First quarter, 25%, next, like that, right? And then there are ways and means of how do I construct a box plot and all. Right? If I get into it, it is too tedious. Right? But let's go and read on box plots and what is the real power of box plot. Let's say this is the power consumption by 4 different houses in a specific month. Units, y-axis can be units, x-axis can be A house, B house, C house, and D house, right? So such large number of data to be compared, A and B, this is the central median. Okay. A and B typically follow a same consumption. Around the median, there is much more distribution or deviant distribution you see among C and D compared to A and B. Right? In fact, there is more powerful interpretations possible with box plot. But I think in the interest of time, right, the size of the box, right? I think, right, what is the overall size of the box? What is the size of the upper quartile and the lower quartile? What is the size of the lower tail towards the whisker, upper tail? All those stuff can help me come up with key inferences. Right? So that is what I'm answering there. These are how do I draw a box plot. Just listen to some YouTube tutorial, you will get to know how to draw a box plot. Okay, right. So I think I will wind up here. Right. If any questions are there, I'll come back.
Yes. So, audience, any questions? Please raise your questions.
Thank you very much, sir, for this beautiful explanation. In fact, there is no specific question, but I would just like to know if you have any, current research in this descriptive statistic field. So you can briefly share with us, please.
Yeah. So I think the way I see descriptive analytics, this is actually the flow chart that needs to be definitely followed for doing any analytics of interest. Right. So because people, I think now Python package is a 5-line program can do data classification, clustering and all. Python has made it machine learning as a printf call, right? But people are using all these things without even knowing what data should they actually focus upon. Correct, right? So in fact, you can, I think what we are also trying to focus is how do I use some of the ML concepts actually to do, I think just to give you an example, right? There is a statistical concept of what is called as LSI, which stands for latent semantic indexing, right? So in fact, when the web data, right, when the information retrieval from the web, right, typically the web is stored as a M cross N matrix, right? Where D1 to DN are websites, and each D1 document is containing what all terms, correct? But eventually to process, not all data stored in the websites are important or interesting. So that is where people are interested in reducing the size of the data, or what is called as data dimensionality reduction. Many more techniques are there, correct? But typically these have, most of the data dimensional techniques have evolved from a statistical point of view or mathematical point of view. Okay. So what I'm meaning is a singular value decomposition, right? Latent semantic indexing is basically to reduce the size of the data to more important stuff in the data. That is where what the current, what we did is, can we do better LSI? Because I think the frequent pattern mining concept and all, which comes in ML, right? So that ML can actually make the statistical power even more enhanced. Right? So I think I'm answering that from a research perspective question you asked, right? So how do I enhance the, I think somewhere statistics, this is the joke they say, right? Statistics also hides more than what it reveals, right? So you can fine tune the statistical power to suit your application. That is where you can tap your predictive analytics. But I think I have forgotten to bring that slide. The father of statistics, Deming, as they call, right? W.H. Deming, right? 1900 or 1901. Enough of statistics is there. 60% of your analytics tasks can get done if you do a good descriptive analytics exercise. I hope somewhere I touched upon this. Research to find out something new is difficult, but you can possibly add the power of ML to make your descriptive analytics closer to the application.
Thank you, sir. Thank you.
Any other question from the audience? Maybe Ananta Padmanabha Reddy should ask a question.
Attendance will be granted to people who ask questions, sir.
It's not like that. Sir. It's not like that. Because,
Then just for fun. Then 8 o'clock, let them go out happily.
yeah.
Yes.
Because Ananta Padmanabha Reddy was my student.
Oh, acha, theek hai, okay.
Yes, sir.
And
Yeah.
also he worked in data mining related area.
Oh, sorry.
Yeah.
Go ahead, sir.
Sir, the descriptive analytics, as you said, no, sir. Actually, so even when when the case study, any case studies when we are taking, for example, like in agriculture or any of the data.
Any data set, agriculture, weather data set, anything.
Even currently, I'm handling that introduction to data science course. As I have given, my students are working with this like descriptive statistics and with the different case studies actually.
Very good. Application data is different. That's it.
Application data with some 10 teams I have divided. Every team is working with a different type of data.
Very good. Ask them to explore all plots possible, and Python is excellent in its package support. They don't have to write any code also. Just density plot, rug plot, many more are there. A violin plot.
Yeah, yes.
Just a search. The power of descriptive analytics is great.
And one more thing, actually, as per syllabus, it is in R. Even I have given that R language is.
Yeah, fine. R Python. R is, I think, typically, I think for statistics power, in fact, R is much more dedicated than Python from descriptive analytics. So R is also suited.
Yeah, yes. Even I can give a liberty to that students to do in Python or
yeah,
R.
That's what we do in our course. We make it choice. Either you do it in R. See, if you want to give a clear-cut pointer, Python is more dedicated towards predictive analytics, whereas R is more dedicated towards descriptive analytics, because that's the way it started out. Correct.
Yeah, sir. That difference I need to have it.
But I think my suggestion would be allow the students to explore whatever they want.
Yeah. I have given a choice. Yeah.
We do in Python. Excellent. It's a nice interaction.
Thank you, sir. Thank you.
So, any more question? One question, please. Any more? One question.
Sir, question. Hello.
Yeah.
Yeah, go on.
Sir, whether depending on plots is whatever the output, is it helpful us to decide the algorithm, machine learning algorithm, which type of algorithm we can apply based on the plot output?
Excellent question, right? So, should I apply data class? See, whether you should apply data classification, but see, let's say you're interested in data classification, right? I think cancerous or non-cancerous, two possible classes. Like that, many applications you can have different number of classes. But which all attributes, feature vector as we call, right? I think there's an area called as feature engineering, right? So which features in the data will have a role to play in my classification, right? So that which data is important, right? So those relationships, that will get spelled out when you do all these plots, right? So arriving at a feature vector, right? See, whether it's classification or clustering, right? I think if you're meaning classification and clustering ML task, right? So that will depend on whether you have training data, or is it only one overall data you have? But to do in the classification algorithm, right? For example, decision tree or Bayesian, which are all, in fact, if you look at some of the decision tree algorithms and all, right? The internals behind which attribute should I start up with and all will be based on pure statistics, entropy, information gain, all these are statistical measures. So when you plot these attributes, right, so they will give that interrelationship. I have just covered the tip of it, right? Nothing, not even 5% of the plots I have touched, right? So these plots, summarization tools, right, will give you the very important answers as to which part of the data do I focus upon.
Yes, sir. Yes. Sir.
Yes, sir. Excuse me, sir. One last question.
Yeah,
Good
you can
evening,
go.
sir. Sir, actually, when we have a data that respect with any of the application, that may be of medical or agriculture or whatever it may be, we have n number of plots. For example, if the population is data is there, as one student asked today itself. So, which among all the plots, which plot is appropriate? There will be some at least benchmark or something like. For example, if populations are there, we will use in the pie charts. Uh, like so, based on the problem or based on what we need to do that analysis. So appropriate visualization techniques can be suggested, or any other benchmarks or
Okay.
any.
See, one generic at the outer level, right? See, if you are working with population, actual population data, right? Then I think these plots typically presume it is actual population data, right? But if it is a sample data, typically as a statistician or from the descriptive analytics point of view, people suggest more to lean towards the inferential analytics, like test of hypothesis and all you do, right?
Yes, sir.
They have, you can work with plots even over sample data if the samples are quite large and exhaustive or representative. But the real mathematical power, when it is a sample, comes out more out of inferential analytics. That is when the test of hypothesis and all has a role to play.
Yes. Okay.
I hope you have, I think you understood, right? So when it is very narrow sample you have, right?
Yeah.
Let's say
Based on
20,
sample. Yeah.
let's say 25 states, but you have sampled only 5 states, and each state the average population is 1 lakh. You have sampled only 1,000, right?
1,000.
So then it is more of inferential analytics.
Inferential. Okay.
That's what test of hypothesis. I think, sir, the coordinator has a session on test of hypothesis. I think I did see.
Yeah, sir, it is there.
So that is typically recommended more powerful for sample.
Okay.
If it's a really very skewed small set you have.
Okay. Yeah.
You can, but then the conclusions you come out of plots over such small samples may never be conclusive. That's the reason we do it.
Yeah, that conclusion may go wrong because our data sample size is
correct. That is where, because the test of hypothesis, you have, I've forgotten the number of degrees of freedom, some standard empirical table they will have, right? So the statistical measure, what is it called, null hypothesis and
alternate hypothesis.
Alternate hypothesis, you either accept or reject the hypothesis. So whatever the sampled data values you compute is actually related with the benchmark value with which that exercise has been conducted over large number of trials. Right? So that is where they are bridging the gap between sample and population.
Sample and population. Yeah. Thank you, sir. Thank you. Nice.
Yeah, nice interacting with you.
Yeah.
So, thank you, Professor Balasubramanian.
Thank you, sir. Thank you for the chance.
For excellent talk. Very interactive talk with descriptive and predictive data analytics. So, thank you, sir.
Thank you, sir. So, I'll pass on the slides to you. You can share it to the participants.
Yes, sir. Yes, sir. So, now let us move on to the next speaker. Our next speaker is from IIIT CCT itself. Professor Srija. She is going to talk about central tendency and dispersion and its measurement. So, to introduce Professor Srija, Dr. Srija received her BTech degree in Information Technology and ME degree in Computer Science and Engineering from Anna University. She did her PhD in the Department of Computer Science and Engineering from Indian Institute of Technology, Kharagpur. under the guidance of Professor Debasis Samantha and Professor Pavitra Mitra. She received her PhD in July 2020, and then she joined IIIT CCT in November 2020. So she is with us for past 2 years here. She is working as an assistant professor here. Her research interests include biomedical signal processing, brain-computer interfacing, data analytics, environmental impact analysis. She has, to her credit, several research papers published in peer-reviewed journals and some of the high-quality conference proceedings. So with this introduction, now I hand over the session to Professor Srijar.
Thank you, sir. Thank you for the introduction. Hope I'm audible.
Yes, madam.
Yeah. Okay.
Yes, ma'am.
Thank you. So yesterday, we had the session on big data analytics and measurement of scales. And today, we had it on brief introduction about descriptive statistics. So in the same line, I'll be continuing with the measurement of location, measures of location, and measures of dispersion. Okay. So yesterday we have seen measurement of scales, right? Okay. So we have seen nominal, ordinal, interval, and ratio. May I know like what is the difference between interval and ratio scale?
Ma'am, the main difference is in interval scale we are keeping the arbitrary zero, and in the ratio scale we have the absolute zero.
So what is absolute zero? Can you tell me an example for that?
Say for example, whatever characteristics we are measuring, we can set it to the zero also. That means, for example, if I'm measuring the weight,
Mhm.
so weight I can set as zero also. But in case of interval scale, say for example, if I'm measuring the temperature, I cannot set it as zero in case of the Celsius or the Fahrenheit scale. So we are keeping the arbitrary zero to maintain the equal distance.
Okay, good. Okay, this is the right answer. So, in case of like interval scale, we have zero. Okay, and we have like negative and positive values, but that zero, whatever we define there, it is not an absolute zero. For example,
Yes.
temperature in Celsius and Fahrenheit. If we say the temperature as 0 degrees Celsius, it doesn't mean there is no heat, right? So there will be a small heat. Okay, but in Celsius scale, we are giving it as like 0 degrees Celsius, but the same temperature if we take it in Kelvin. May I know like what is 0 Kelvin in Celsius?
I think it is around 273 point something.
Is it 273 or minus 273?
I think minus, ma'am.
Yeah, yes, right. Okay, so 0 Kelvin is minus 273 degrees Celsius. So where the particle doesn't move and all the properties disappears there. So that is where the absolute zero comes. So wherever we have absolute zero, so that it will come under like ratio scale, and where we don't have absolute zero, that will come under like interval scale. So we should know this clear difference because we are going to see what is nominal, what is ordinal, and what is interval and ratio, and what type of measures of location we are going to apply for each category. So we should know the clear difference, only then we can go for this. Okay. And I my interest is, and my research is on like brain computer interface, and I got interest on data analytics due to a particular experimental design. I will share that knowledge with you, like why I got interest in data analytics, and I jumped into like Python. I'll share in between. Okay. Okay. Hope my screen is visible.
Yes,
Yes,
ma'am.
ma'am.
Yes, yes.
Yeah. Okay. So can someone tell me like what is TRP? So leave this. Okay, I am presenting it. So we always care about, right, the whatever channels are there, they always care about TRPs. Okay, they always work on, they always run behind TRPs. Whatever shows are there, they run behind TRPs. Do you know like how it is collected?
Yeah, for some sample houses, they put some instrument
Hmm.
They find out during which time, which channels they are watching.
Yeah, yes. Actually, earlier time we had only Doordarshans, right? Okay. Okay. In my time, okay, the cables, everything started, but earlier we had only Doordarshan. So what they do is like they will have a people meter and they will put it in some homes and they will collect it for a particular period. Okay, so they will check like okay at what time people watching like what series or what things. So based on that they calculated the TRP. And nowadays we have every in most of the houses we have set top boxes, and in set top boxes okay they have people's meter and it estimates like okay what people are watching, okay, at what time and what people are watching. So based on that they do the calculation. So can you tell me like what is the population here for this TRP? So what can be the population? So let's take like okay we are taking about for the entire world. So what is the population here?
Number of set boxes.
Number of set of boxes. Okay, fine, that can be taken. So number of set of boxes or number of TV viewers. Okay, so both can be taken. Number of TV viewers or number of set of boxes. Okay, so these can be taken as the population. So can you tell me like what can be the sample here? What will be the sample?
It depends, ma'am.
Yeah, just one example for sample.
People's meter.
No, people's meter is not the sample, right? So you said the population as the okay set-top boxes. So whichever houses is having set-top boxes, it can be considered as the population. So can you tell me like what can be the sample there?
The few percentage of the total data.
Yes, few percentage of total data. So how it can be, how it will be selected?
Maybe randomly.
Yeah, randomly. Good. So it will be like completely random. Okay, so randomly few percentage of the entire population will be selected and that will be considered as the sample. Okay, so as sir said, statistical inference, right? So that statistical inference comes from this sample statistics. So you have a population and but okay dealing with the population is very hard because the population will be like very big. So what people used to do is like they will take a sample from the population and in the sample they will do some statistics which is called as sample statistics. Okay, so whenever we are doing a statistics on the sample, it is called as sample statistics. And from the sample statistics, we will come with the inference about the entire population. So this is what statistical inference is. Okay, so we have a population, take some sample and find some statistics over the sample which is called sample statistics, and from the sample statistics we will be inferencing over the entire population. Okay, so this is called statistical inference. Hope I am clear with this, right? Okay, so let's see like okay each terms. So here we have like a data. So for TRPs, so these are the attributes. So age can be the attribute and the gender can be the attribute. Whether the viewer is like happy or whether he is feeling sad, it can be the attribute, and how many hours they are like watching. So it can be the attribute. Okay, fine. So what is the population here? So okay, as you said, the set of boxes. So whichever homes is having set of boxes, it can be considered as the population, or all TV viewers in the country or the world can be considered as the population. Okay. So note here, like all people in the country or world is not a population. That is the entire people. It's not a population. So whichever like interest, whoever okay for a particular problem, whichever we are taking into consideration, so that will be considered as the population. Fine. So what is a sample? So a sample is a data set consisting of a population. So for example, you have a school and you want to consider the standard of a school, right? So what you are doing is you are taking class 12. So randomly you are taking one class, so which is like class 12. So the class 12 will become the sample. So based on the class 12, okay, the student standards or the student knowledge, you are going to okay guess the standard of the entire school. So that is what the sample here is class 12. Okay, and the entire school population is the population. Fine. So the statistics, as I said, a statistics is a quantity calculated from the data that describes a particular characteristics of a sample. So the sample, so whatever we are calculating from the sample. So what are all the things can be calculated from the sample? Can you tell me, like, what all can be calculated from the sample? Statistics.
Maybe the channels being viewed by those people.
No, here just okay. Don't go that way. You
Okay,
just
excellent.
say like you have the data.
Mhm.
Okay, you have like okay number of hours they are watching, something like that. So what can be calculated from the sample?
So it can be average number of.
Yeah, average number of hours. Okay, then
Statistical measurements like
that's what
mean.
statistical measurements. What are the
Minimum,
yeah,
We can
maximum,
say
mean, median,
mean,
mode.
median,
Okay,
mode.
yeah,
Okay.
more many things. Okay, so all these are sample statistics. So whatever you are saying statistical measurements, all these are sample statistics. Okay, so the statistical inference is the process of using sample statistics to make decisions about population. So this is very important. Okay, so you are taking the sample, you are finding the sample statistics, and with this sample statistics you are going to make decision over the population. So listen here, here you are not going to use the entire population at all. You are taking a small sample and you are okay using some statistical measurement over the small sample, and then you are getting inference over the entire population. So this is what statistical inference is. Fine. Fine. So data summarization. So how the data can be summarized. So there are like two things. So one is measures of location. The other one is like measures of dispersion. So let me ask you one question. So let's take a data. So in the data we have like a cricketer's name. Okay. So whoever is batsman or bowlers. Okay. We have Indian cricketer's name, and then their scores, and then we have like jersey numbers. Okay, so can we take average of jersey numbers?
No,
no.
Okay, why can't we take?
it doesn't make any sense. Doing average.
Yes,
Jersey
right.
numbers may be random, I guess.
Okay, so some cricketers have some jersey numbers, right? So Kohli have 18 and Dhoni have 7. Okay, some jersey numbers are there, and adding that or okay taking some statistics or some applying something over that doesn't give you any sense at all. So what can be done over the scores?
Yeah, scores can be like average can be found, maximum,
Just
minimum.
to compare among all cricketers,
Hmm.
we can find out the average measures.
Yeah, yes, okay, we can find the average measures and we
Average
can,
runs they scored or average wickets they took.
yeah, that's what. Okay, so we can see like okay which batsman has the highest scores, and who for the current year who have scored like a higher scores. Okay, many things can be like taken from the just one simple table, right? So here can you tell me like what can be the measures of location? What does the location term mean here? Why it is called measures of location?
No idea, maybe.
Okay, so measures of location. So see, you can have a very big data. So, but with a single value, you can okay think about the entire data. For example, see, you have cricket scores. That is okay. Some match is going on. Okay, and you know the run rate, right? If you know the run rate, so can you predict like what can be the score after like 20 hours? Sorry,
Yes.
20 overs.
Yes.
Yes, right. So this run rate is a single point. Run rate is a single point which is average. So with this average, you can predict the okay what will be the score after like 20 overs, right? So this single point gives you the description about the data, right? So this is what measures of location is. So single point, so location, single point. So a single point gives you the description of about the data. Okay, and measures of dispersion is the spread of the data. So it is not a single point. So it gives the spread of the data. It defines the spread of the data, and from the spread of the data you can define like many things. For example, in certain cases, a measure of location will not be a good measure. Okay, you cannot use measure of location. So in those cases you have to go for like measures of dispersion. We will see like where we need to apply measures of location and where we need to apply measures of dispersion, right? So the measures of location. So these are the measures of location. So mean, median, mode, and mid-range. So okay, sir, Sivalan sir has already talked. Okay, he spoke many things about like all these things. Just one question for me. So see, you are going to purchase a flat or something. Okay, you want to purchase a villa, and you are going to a particular place, and in that place you have like 20 houses, and when you ask about the prices, so people are saying, one agent is coming and he is saying that okay, there are like 18 houses which is of like 1,000 square feet area, and the price is like 20 lakhs. And there are two houses which is of like higher square feet, and the prices is like around 40 and 45 lakhs. So here the average is okay, the average here he is saying it as like 25 lakhs. So can we take that average as the right value, or should we go for like some other value?
No, because in measures of central tendency,
Hmm.
extreme value affects the result significantly. Then we should not go for that.
Will okay, does it affect all the measures of location,
Yes.
or no, it doesn't affect all the measures of location. It affects only mean. Mean is affected by the outliers, not the median, not the mode.
Hmm.
True, true.
Okay, so mean is affected by the outliers. So we cannot take mean as that is average price, whatever they are selling, right? So the average price of that particular location cannot be taken as the proper measure. So in that case we have to take the median. So we have to check like median price of that location, and we have to take median price as the measure. Okay, so mean is affected by outliers, median and mode will not be affected by outliers. Okay, so this we need to know. Fine. So and there are like okay, these can be measured in like three ways: distributive measures, algebraic, and holistic. So I'll not be going into that, okay, because time is less. I'll just tell you like what are the functions available. So in distributive measure, okay, we can use the sum, count, maximum, and minimum for the entire data set. Okay, and in algebraic measure we will be using the distributive measures. We will be using like two or three distributive measures. For example, average equal to sum by count. So this is algebraic measure. And in holistic measure, it is a measure that must be computed on the entire data set as a whole. So we can use median. So can we use mode here?
If a particular observation occurs many times, then we should go for mode.
Yes, we can also use mode in holistic measure. Okay, we can use median and we can use mode. Fine. So and then we have like some other means. So how we can calculate mean for a sample. So which is like simple mean, and the other one is weighted mean, and it's trimmed mean. Okay, we will just check the formula. So simple mean is okay, just summation of all the values divided by the total number of values. Fine. So this is simple mean. And in weighted mean, we will have a weighted value. So we will have a weighted value. So that will be like multiplied with each value divided by total weight. Total weight. So this will give you the weighted mean. And in case of trimmed mean, what we will do, we will remove the outliers. That is, whichever value is like, if you feel like, okay, whichever value is less and whichever value is like, okay, affecting the data, it is completely up to the user, that is whoever is using the data. So they can remove the outliers, and with the remaining data we can use calculate the trimmed mean. Okay, fine. So this is on like okay, mean of the sample. So now I'll tell you like my story why I jumped into data analytics. So, okay, I did my PhD from IIT Kharagpur, and we had a lab, BCI lab, brain computing interface lab. So what we used to do is like we used to work on like brain signals. We used to put like EEG device over a subject, and we used to see like how the brain signal works. Okay, so when we were collecting data, we had one particular student, and he was from he's from architectural department. Okay, he's from architectural department. He came to us and he said, ma'am, I'm very much interested in EEG. Can you collect? Okay, I have a problem. Can we work on that? But the problem he has given is like very tricky, and we cannot collect data and we cannot publish the data because it is like on hunger. Okay, so whenever a person is feeling hungry, we need to check like how the data is. Can you tell me like why we cannot publish this data? So whoever is doing research, can you tell me like why we cannot publish this data? Okay, because of ethical clearance. Okay, people will not allow like a person to be in hungry and okay to collect data. That is the one reason. Okay, they, even if we go for like publication, they will not accept it because we have collected a data from a person who is feeling hungry, right? So this is one reason. So we just collected the data, we did some analysis, and we didn't publish it. So what was the experiment is in BCI? The main thing is experimental design. So what should be the experimental design is like, okay, the person who came, he didn't eat from morning 6 to 11. So 6 till 11 o'clock he had the class, and 11 o'clock he will come to lab and he will give his data, and then he will go to his hostel and he will have his food. Okay. So the first day he didn't eat anything, he came and we collected the data and he went. And second day we want to check like, okay, if we show some videos of like food, okay, some okay mouth watering food recipes, okay, we want to check okay whether he is really feeling tempting to eat something like that. So we, okay, in our lab, since it was in the Bengal region, our lab consists of like many Bengal people. Okay, so we created some videos, some Bengal recipes, all these things. So he came and we collected the data, and when we were analyzing the data, there were no change at all. We showed the video and then we collected it, but there were no changes at all. Then we asked him like, what happened? Are you not feeling like hungry, or not feeling tempting to eat? Okay, then he said, no Didi, okay, I am from Gujarat. Okay, I don't eat like non-veg. So this recipes whatever you are showing is completely non-veg recipes, so I don't feel like eating. Okay, so he said this to me. So what we did the next day, we collected some recipes from like all over India, which is completely vegetarian items. Then the second day we showed him the video. Okay, and we could see there was a clear okay difference from the first day and the second day and the third day videos. So these are the, can you tell me like what type of plot this is my screen visible? Am I audible?
Yes, ma'am. Yes.
Yeah, okay. So can you tell me like what type of plot this is? This is possible with Python. This plot is done in Python. This is scalp plot. Okay, so this is scalp plot. This is done in Python. Okay, so see, so the first, whatever in the first row, the first row is okay whenever he was like hungry, and whenever we shown the video where he was not feeling tempting to eat. Okay, so this is the first one. And the second okay, the row, so this is like when the video, okay, when he was like at the extreme thing, when he was like tempting, feeling so tempting to eat. So see the energy over the plot, it is like too much, right? The energy is spread over the plot, over the scalp. It was like too much energy is spread over the scalp. And this is during the end of the session, and this is during the starting of the session. Okay, so we could clearly see the difference between the videos, okay, whatever the experimental design. But unfortunately we couldn't publish this, but this was a very nice experiment, and this calplots was completely done by Python, and this data analytics, everything was done in Python. So this is how I jumped into data analytics. Okay, so this research was like okay, awesome. When I was working there, okay, I enjoyed I really enjoyed this. It was very nice. Okay, fine. So we will just move on to the next one. So mean with grouped data. So whenever we have grouped data, so how to find the mean? So there are like 3 steps. One is direct method. So next is assumed mean method and stepped deviation method. Can you tell me like what is grouped data? What will be there in grouped data?
Observations will fall in range.
Yes, observations which is falling in range. So we will be having a class and we will be having the frequency. Okay, so we will be having like three methods: direct, assumed mean method, and step deviation method. So I'll just show the formula and I will tell you like how to calculate that. So this is for direct method. So in direct method, the frequency is multiplied with each xi. So here xi, how the xi is calculated is half of lower limit plus upper limit. So that is, we will have the range, right? So the from the range we will take the lower limit and the upper limit, take the average of that. So that's how this xi is calculated. So frequency into xi divided by the summation of frequency. So this will give, this is in direct method. And in assumed mean method, we will have one variable which is called assumed mean. So how this assumed mean is calculated is, okay, so from the data, so you will be having the data, the middle value. Okay, the middle value will be mostly assumed as a. And if you have two values, that is, if you have like even numbers of values, and if you have two values, either of one can be taken as the assumed mean. Okay, so a is the assumed mean here, and fi is the frequency, and di is assumed mean minus xi. So where xi is again half of like upper limit plus lower limit by 2. Okay, and divided by summation of fi. And the next one is step deviation method. Again, here we have a, okay, and here we have this ui instead of di here. Okay, here we have ui and into h. So here this h is the class size. So what is the difference between the upper limit and the lower limit? And this ui is xi minus a by h. Okay, so we will see an example. So see, this is the class interval given. So this is the classes given, and this is the frequency given. So for in a class, okay, this is the, let's take like, okay, these many what intervals of students. Okay, so two number of students are taking like 17.5 marks, and okay, three number of students are taking like 32.5 marks. Okay, so these are the marks. So here, okay, di is the xi minus 47.5. So can you tell me like what is 47.5 here? So here di is a minus xi, right? Or xi minus a, where a is the assumed mean.
Mean.
So how this assumed mean is calculated? So from this x, you can take the middle value. So here the middle value is, here we have six values, right? So here the middle value is either 47.5 or 62.5. So either of the one can be taken. So here 47.5 is being taken. So that is considered as the assumed mean. Okay, and ui is xi minus a by h, and h is 15. So what is h? The difference between the upper limit and the lower limit is h. So that is how this has been calculated. And finally fi into ui. So this is just simple calculation. So when you calculate using step deviation method or assumed mean method, whatever method you calculate, so the mean of the marks will be like finally 62. So these are the three ways you can use whenever you have the grouped data in your hand. Okay. So mean for a group data, one more thing we need to check with like grouped data is whether the data is inclusive, whether it is having inclusive classes or whether it is having exclusive classes. So inclusive classes in the sense, so you have here 10 to 19. So here, see, the lower limit is not including the upper limit of the previous class, right? So this is what inclusive classes. And in exclusive classes, what will be there is the lower limit of the second class will have the upper limit of the first class. So see, 9.5 to 19.5. So 19.5 to 29.5, and okay, again this 29.5 too. So whenever you have a data, whenever you have a grouped data, and if it is of like inclusive classes, you have to first convert that, okay, data to exclusive classes. Can you tell me like how to convert to exclusive classes?
Upper limit of the current class plus lower limit of the next class divided by 2.
Divide by 2, or the simple calculation is, okay, just subtract minus 5 with the upper limit and the lower limit. Yeah, okay, whatever you said is right. Okay, so it is like upper limit of the first class, okay, divided by 2, just take it. Okay, so it is like 9.5 to 19.5,
Yes.
19.5 to 29.5. So it will be coming like this. So whenever you have like data with inclusive, the first step is you have to convert that to exclusive classes, and then you have to do the calculation. Then you have to go for the step deviation method or assumed mean method. Okay, so this is one example. So here we have like driving times, and here we have like number of employees, and you need to calculate the mean for this. Okay, you can here you can directly use the direct method. So in direct method means, what is direct method? Frequency into xi divided by the summation of frequency, right? So frequency is 3 and xi is, okay, 0 plus 10 by 2, which is 5. So you have to calculate like for each class. So finally you will be getting like 21.8 minutes. Okay, you can work this out. Fine. And some more measures on mean is like arithmetic mean, geometric mean, and harmonic mean. So I'm not going into detail. So these are three means, but you should know like, okay, where, whenever you have a data, okay, where you need to apply these means. Okay, so that I'll be telling. So that's what. So in which situation a particular mean is applicable. So we should know that. So I'll just go for that. So let's take an example. So see, this is an example. So we have rainfall, okay, and we have days. Okay, so these are the like okay, range. This is the days is the range and rainfall is the observation. So we have like two things. So observation and range. Okay. So the first case is range remains same for each observation. So here we have like, okay, the range is same. So we are okay, you are collecting, you are observing it for a week. So week has like 70. So 1 week, okay, what is the observation? You are just taking it. So here the range remains same and the rainfall is like different. Okay, so the observation is different. And in the second case, ranges are different, but observation remains same. So it is like, okay, first day the rainfall is like 50, and for 2 days the rainfall is 50. So it is like this. Okay, so the range is like different. The ranges are different, and the observations remain same. And in the third case, both are different. The ranges are different as well as the observations are different. So for each of this case, you have to, okay, deal with like each of the means, that is arithmetic mean, harmonic mean, and geometric mean. We have seen three means, right? So each of these case will be taking like each of the means. So first let me tell you. So this is case one. So where the range remains same for each observation. So in this case, we will directly go to arithmetic mean. We will just apply arithmetic mean. Okay. And for the second case, where the range is different but observation remains same, so we will go for like harmonic mean. Okay, and for the third case, okay, when both are different, when days are different and rainfall is different, okay, when both are different, and here we will be going for geometric mean. Okay, so we should know like whenever the data is there, whenever you are applying the, okay, means, so okay, you should know like what type of mean you should apply. Fine. Okay, so these are like simple things, the relation between means. So I'm skipping this. Okay, so let's, so we will go to a median of a sample. So we know like what is median. So whenever a data is given, okay, the middle value. So how we will be taking the median value?
Just sort them and find out the middle one.
Yeah, we will be sorting the data and then we will be finding the middle value, right? So okay, so this is the median of a sample, and the same this is for a sample, right? So whenever you have a grouped data, whenever you have a grouped data, finding median is different. So this is the formula we have. I'll show you an example for that. So find the median of a group data representing yearly income of number of persons. So you have income here in the class and you have number of persons here. Okay, so 60 to 69,000. Okay, how many people are okay earning this is like 5, and 70 to 79,000 it is like 15. So these are like number of persons. So first step is, as I said, whenever you have the data which is of inclusive, you have to convert that to exclusive. So this is the income. So you are forming the exclusive group. So this is exclusive group is formed, and then okay, you have to check the median class. So how the median class is found is like, so you have to calculate the cumulative frequency. So these are the frequencies, right? So you have to find the cumulative frequency, and you have to find the total sum of cumulative frequency divided by 2. Okay, so sum of cumulative frequency by 2, and whichever is like nearby that cumulative frequency, that is n by 2. So when you calculate the cumulative frequency for this, that I think we will get like 49. Yes, n by 2 is 49. So we'll be getting like 49. So whichever is nearby that 49. Okay, we should always take the higher value. So we should take the higher value, whichever is like nearby 49. So with this 70 is like nearby that. So this will be taken as the median class. So this median class, it will be considered. So from this, okay, we will be substituting each value in the formula. So in the formula we had L. So L is the lower limit of that median class. So lower limit is 89.5. So it is 89.5. Okay. And here n by 2. N by 2 is the sum of the cumulative frequency by 2. So which is 90, okay, I think 98 by 2, which is 49. Okay. And then cumulative frequency. So this cumulative CF, this CF represents whichever is the median class, the cumulative frequency above that. Okay, so this is the median class. The cumulative frequency above that is this CF. So CF is 40 divided by 30. So this 30 is, okay, so whatever the frequency of that particular median class is 30 into 10. So this 10 is the difference between the classes. Okay, so upper limit and higher lower limit is 10. Okay, so just substitute, we will be getting the median value for the grouped data. Okay, I hope you understand, right? So this is like simple maths. Okay, so from this, first you have to find the median class. So once the median class is found, we can just substitute all the values from that, and we will be finding the median of the group data. Okay, fine. So mode of a sample. So how the mode is found? So mode is like the most frequently occurring data, okay, value in the data. So that will be the mode. So again, we have like mode of a grouped data. So this is the formula for mode of a grouped data. So let me show you an example again for this. So see, we have like, okay, marks and we have frequency. So from this, uh, do we need to do exclusive group here to this data? Hello?
No idea, ma'am.
Actually, here we no need to do any exclusive groups because the given data itself is exclusive. See, 20 to
Yes.
30, yeah, 30 to 40, 40 to 50, 52, because the given data itself is like exclusive group. So we no need to convert this into like exclusive. So here we need to find the model class. So whenever the data is given, how the model class is found is like wherever the frequency is very high. So here the frequency is very high. So this will be considered as the model class. Okay, so once the model class is found, and then it's very simple, we have to just substitute the values from the model class. So mode equal to L. So what is L? L is the lower limit of that particular class, so 50 plus, okay, and F1 minus F0. So see here, everything is given. Okay, so F1 is the frequency of the model class, which is 30. F0 is the frequency of the previous class, which is 18. Okay, and F2 is frequency of the succeeding class, which is 27. So we will be substituting everything into the formula. So we'll be getting the mode. Fine. So this is for like how to calculate median for the group data and mode for the group data. Okay, simple calculations. I'll be sharing the slides so you can like just go through. So when you're taking classes, you can give problems regarding this to the students. Then, so relation between mean, median, and mode. So okay, before this, I'll just show you some code. Hope my screen is visible. Can you see this notebook?
Yes, ma'am.
Okay, so I'll just show this. So we will be using this import pandas as PD, okay, because I used to mostly work on like data frames. So we will just use this import pandas as PD and this matplotlib to check the plots, okay, whatever plots is being taken. And here, okay, we have like two series. One is runs and the other one is rating. Okay, so see, we have created series of runs and we have created a series of rating. So when I, okay, run this, so see, everything is in like, okay, runs, it is not in a proper format, right? So this is just simple. Okay, it is kind of an array kind of thing. It is not in a proper format. So what we have to do is like we can make use of like pandas and you can create a data frame. So this score, whatever score is being created, okay, I'm giving into like pd.data frame of score. So this will create the data frame. So see, you can create a proper data frame which will be in a proper tabular form. So you are having runs and you are having ratings. Okay, so now if I apply mean to this, okay, to this entire data frame, if I apply mean, so what will be my answer? So will I get mean for the first column, or will I get mean for the second column, or will I get mean, whatever mean it is calculating, is it for the total data, whatever is available? So what will be my output?
Mean of the total data?
No, okay, this is what the pandas will do. Okay, so the pandas, what it will do is like it will calculate the mean for this column separately. So see df dot mean. Okay, if I run this, so see for the runs it is giving a separate mean, and for the rating it is giving separate. Okay, so this is what, so it will give like, okay, means you no need to write any loops, no loops, nothing. Okay, so just take the data frame and use the function, default function mean. So it will give the mean for the columns, whatever different columns available, it will give the means. Okay, so it is giving like, okay, the mean as 31.8 for the runs, and similarly it gives the median value. Median is 30.8 and rating is 3.8. And similarly for mode, if we calculate, so we are having like 30.0 and others as nan values, and here in rating we are having like many values. So can you tell me like why in the rating we have like many values, why it is not sticking with like only one row? See, this is my data. Yes, this is my data. Okay, so I have like this is the runs. So in the runs, can you tell me like what is the mode of run? So this is the runs, right? So what is the mode of the runs?
It can be 30.
Yeah, it is 30 because 30 is occurring two times.
Two times.
So yeah, rating, can you tell me like what is the mode of this rating?
I think there is no number repeating.
Yeah, there is no number repeating. So then what it is showing here? So when I, okay, took this mode df of mode, then what it is showing here?
All of them occurring one time?
Yes, all of them occurring one time. So it is just sorting it and it is showing like, okay, all the values. And that's why here it is like nan. Okay, so it is showing like only the top values. So in case if I change, okay, one of the value. So what is like, okay, 4.80 is there, right? So let me change this as 4.80. Okay, run. So median. So can you tell me like what will be the value now?
4.80.
Yeah, only. Yes. Okay. So the runs is like 30 and the rating will be like 4.8. So this is what the use of Python is as pandas. Okay. So the pandas will do everything. You no need to write any loops. Okay. It will automatically calculate for each and every column and it will give you the result. And one important, okay, function in pandas, that is in data frame, is describe. Okay, so whatever we have seen till now, measures of location, mean, median, mode, okay, apart from that it will also show some other things. So we will see here. So see, for runs and for rating, for both it is showing the descriptive things, descriptive stats. So it is showing the count, it will show the mean for each, standard deviation for each, minimum value for okay, runs and rating. This is percentile, 25 percentile, 50 percentile, 75. I'll tell you like what is this percentile is. This will be using in box plot, and finally it is maximum value. So for each, okay, so this describe function gives you the entire statistical measurement for the data. Okay, so this is like, okay, the data whatever we have is completely numerical data, right? So what happens if we have like categorical data or nominal data? So if I try to take the descriptive for the categorical data, what happens? Will it work or will it show any error, or what will happen if I use this describe over the categorical? What is categorical data? Nominal or ordinal, right? So when we apply over like yeah, names of a person or something like that, what will happen to this?
It will
You
give
should
error.
not, yeah, you should not give numbers.
Okay, so you're
it,
saying it will give you a throw an error.
it must give error.
Okay, fine. Okay, let me show some. Yeah. So see, this is one sample data set which is available in Python itself. So in order to take that, I have used this Cbound. So we will see this clearly in detail in hands-on experience. Okay, so in the second week, we will be okay talking about all the packages available in Python. So out of that, one is Cbound, which is an visualization tool. So Cbon is to create, okay, used to create like many visualizations in Python. So in Cbon, there are like a lot of default data sets available. So from that, I'm taking one of the data set, which is tips. Okay. So tips is being taken. So see tips.head. So it will plot the first 5 rows available in that data set. So you have like total bill and how much tip is being given to a particular server, and what is the gender of that particular server, and whether not server, okay, the person whoever is eating, whether they are a smoker, and what day it is, okay, time and size, okay, everything is there. So out of this, can you tell me like what are all the categorical variables here?
The smoker, day, time, and sex,
Yeah,
I guess.
smoker, date, time, sex, okay, everything is like so we have, if you see, okay, there are like 244 rows and 7 columns. Okay, so let me take the data. So just, so I'm taking, so from this, what I'm doing is I'm just taking only tip and I'm storing it in like this one, and I'll just describe this. So this new def, okay, dot describe, it is okay taken over again the descriptive, numerical data. Okay, so I here I'll just take time. So time. So from the data, I'm taking time. So this is the data. Okay, new def. Now let me describe this. So see, count is 244, unique is 2, okay, and top is dinner, and frequency is 176. Okay, so describe will not throw an error. For categorical data also, it will give you something, okay, some descriptives. So here 244. 244 means there are like 244 values in that is what we have taken time. 244 values in time, and unique is there are only 2 unique values. Okay, one is dinner, the other one may be like some other thing, and
Lunch.
top is dinner. So top is dinner means okay, many times dinner is occurring like many times, which is like mode. Okay, so the mode is like okay, dinner is occurring many times. How many times it is occurring? 176. So for categorical values, we will be always dealing with mode, right? So this describe will give you the complete details about that. Okay, so how many total values, and what are the unique values, and what is the top value, and okay, how many times it is occurring. So this description will give you the complete okay mode details about the data. Fine. So this is what the difference between mean, median, mode. And let me ask one more question. So if you have nominal data, so what kind of Neuer topology you have to follow? Sorry, not Neuer topology. What kind of measures of location you should apply if you have nominal data?
Locational?
That's what in measures of location we have seen 3 things, right? Mean, median, mode. So which measures of location we need to apply for nominal data?
Mean.
Are you sure?
Nay, or if it is nominal, I think it is mode.
Yes, for nominal it is mode. Okay, we cannot apply mean to a nominal data because nominal means names or some other thing, right? Okay, names or color of the sky. Okay, something like this. We cannot apply mean to a nominal data. So whenever we have nominal data, we can apply mode. So for ordinal data,
Median.
Mean,
yeah, for ordinal data, median is the right measures of location. And if you have interval data which is not skewed, I'll tell you like what is skewed. Okay, so if you have like interval data, so then what you can apply? If you have interval data, then what you can apply, which measures of location you can apply? This is the connection between scales of measurement and this measures of location. So we in scales of measurement we have seen four, right? Nominal, ordinal, interval, and ratio. So here we have seen three measures of location: mean, median, and mode. So we should know like, okay, to which measure of scales which measure of location need to be applied. So for nominal, mode; for ordinal, median; for interval it should be mean, always mean; and for again ratio it is mean. Okay, but whenever it is skewed, when the interval get data whatever it is given, if it is skewed, then mean is not the right measure, then we have to apply median. Okay, median is the right measure whenever you have interval or ratio scale which is skewed data. Fine. Okay, so I'll show like one more thing here. Okay, fine. So relation between mean, median, and mode. Okay, we can see like now three categories: symmetrical data, positively skewed data, and negatively skewed data. So whenever we have a data and whenever it is of like, okay, completely normal distribution, then all the mean, median, and mode will be lying on the same line. Okay, so then this is called symmetrical data. So whenever you have a data which is like completely normal and all the measures of location will be lying on the same line, right? And whenever you have like positively skewed data, so whenever you okay, the positively skewed data happens, the mode will be okay, so mode will be like always less than median, and median will be always less than mean. So this is for positively skewed data. And one more thing is like all the larger values. Okay, so the tail is towards higher value. Whenever you have this tail, the tail will be towards the higher values. So from this you can like check whether it is like positively skewed data or negatively skewed data. And for negatively skewed data, okay, the tail is towards the lower values, and then mode will be greater than median, median will be greater than mean. So these are the differences between the skewed data. Okay, so again I'll show this in okay, pandas. So sorry, I'll take again like a tips. So, okay, in the tips data set, there is a column called a tip. Okay, when we are describing that, it is having like 244 values, and it is showing what is the mean value, minimum value, maximum value, and it is showing all the percentiles and then standard deviation. Okay, so now from this, we will take, okay, I'll just show you the histogram for that. So, see, this is the histogram plot. Okay, whatever we got for the tip. So can you tell me like, okay, whether the data is having outliers?
Yes.
Yes. Okay. So the data is having outliers. So the outliers, can we predict that clearly from the histogram? Or which plot is best for, okay, detecting outliers?
Box plot will be better to.
Yeah, box plot will be always better to detect outliers. Okay, and in the histogram we can see whether the data is skewed or not. Okay, so see here, here you have mode, and here you have median, and here you have mean, right? So can you tell me like whether it is positively skewed or negatively skewed?
Positively skewed.
Yeah, this is positively skewed because mode is like greater, right? Sorry, mode is lesser than median, median is less than like mean, so it is like positively skewed data. This is positively skewed data. Okay, so the skewness can be understood, clearly understood from histograms. So in okay, pandas, we have histogram plot which uses hist function. So for using his function we can, okay, just plot it, and okay, from the plot we can clearly see whether the data is skewed or not. Okay, fine. Yes. So fine. And one more measure of location is mid-range. But mid-range we will not be using much, okay, whenever we are doing analytics. But what is mid-range is, it is the average of the largest and the smallest values in the set. So whenever we have this data, so 35 plus 2 divided by 2 will be giving the mid-range, but we will not be using much. Okay. So this is a quick quiz. So please study this and okay, read the options and tell me like which is right. So during a 7-day period in July, a meteorologist recorded that the median daily high temperature was 91. Note that it is a median value. So which of the following statements are true? The high temperature was exactly 91 percentage, sorry, 91 degree on each of the 7 days.
B.
B.
B for Bombay.
No. The high temperature was
Ma'am, third
never.
one. Third, ma'am, third.
Madam.
C. Yeah, 3. Okay, the third is the right answer.
C, ma'am, C होगा
Yeah,
third.
C.
जी,
C. Okay, C is the right answer. Third only is the right answer, because the high temperature was never lower than 92 degree. Here you have only median data. There is nothing else. You have only median data, but you don't know like okay how much values are higher, how much values are like lesser, right? But you know some values are lesser than 91 and some values are greater than 92. But we cannot say that okay it was never lower than 92. So this cannot be the answer. So half the high temperature was above 91 and half were below 91. So this is the answer. Third is the right answer. Okay. So now the next one is measures of dispersions. So we have seen like measures of location, all the things. Okay, now it is measures of dispersion. So sometimes location will not be the right measure. Okay, so we need like some other measure. So we will be using this dispersion. So the dispersions are range, variance and standard deviation, mean. So see this range and mid range is different. Okay, mid range is for measures of location and this range is for dispersion, which is different. Okay, and variance and standard deviation, MAD, mean absolute deviation, absolute average deviation, and interquartile range. And this interquartile range is very important to calculate the box plot. So this quartile range we will be giving in the box plot. So, for example, let's consider like okay, two samples of juice bottles. So, sample A is like Pepsi, and sample B is like Miranda or Fanta, something like that. Okay, and sample A, there are like 5 samples it has been taken, and in the first bottle it was like 0.97 liters, and in the second bottle it has 1 liter, and the third bottle it has for 94.94 liters, and third bottle is again this, and for fifth bottle. And sample B, okay, these are the okay volume of juice content in the second one, which so first is Pepsi and the second is like Fanta. So when you take the mean of the first one and the sample, okay, second one, can you tell me like what will be the mean for both?
It may be same.
Yeah, same for sample A and sample B. But okay, can you tell me like see for in the first one, okay, so it is like 0.97 and this is 1.06. So the sample B, whoever gets this sample B is the luckiest person because he got like a higher juice, right? The quantity of the juice is higher. And in the third one, see, this is 0.88, which is very low. Okay, and this is 94, it is okay. So the okay in what I want to say is like the first sample is having like somewhat okay, which is like greater than 0.9. All the quantity, the capacity of the juice is like okay more than 0.9. But in the second sample, okay, sometimes it is very high and sometimes it is very low. So whoever gets this 0.8 test is the like unluckiest person, right? So the quantity of juice is like very less. So in these cases, the measures of location is not the right measure. So we need to have like something different. So this is where we will be using measures of dispersion, that is variance, standard deviation, all these things. Okay, so fine. So what is range? So range is like, okay, so whenever you have a sample, so arrange it in order. So take the maximum minus minimum. So this is the range. Okay, so it defines the like maximum spread. So what is the spread of the data? So we can get it from this range. Okay, and then variance and standard deviation. So all these are like normal formulas. So I'm not going into detail. Okay, so then we have this coefficient variation. So this is like very important. So whenever you, okay, that is standard deviation, whatever we calculate, it is like spread about mean. The standard deviation tells you like how much it is spreading about from the mean, how much it is deviating from the mean, right? So and should be chosen only when the mean is chosen as the measure of central tendency. So in case if, okay, the data is like not proper, and if the data is like skewed or something like that, then we can go for this coefficient of variation, so which is given by sigma by, okay, x bar into 100. So this is one measures which comes under like dispersion. And next, mean absolute deviation and this absolute average deviation. So all these are measures of dispersion, okay, which we will be using whenever we have like outliers in the data. So that is what, so the mean can be distorted by outlier, and the variance is computed using the mean, and it is done sensitive to outlier. So in order to overcome that, we will be using these measures, which is mean absolute deviation, which is completely based on median value, and the other one is absolute average deviation. Okay, so this is AAD. So these two can be used when there are outliers in the data. Right? And the next one is the final one. So it is interquartile range. So this interquartile range is very important, and this is where, okay, this interquartile range will be we'll be seeing in the box plot. Okay, so IQR, so we should know like what is percentile and quartile. So we will see like what is percentile. So in interquartile range, we will be having like three quartiles: Q1, Q2, and Q3. Q2 is nothing but the median. Okay, but we have Q1 and Q3. So Q1 is 25 percentile and Q3 is 75 percentile. So what is this percentile is? So see, this is the definition. So when we have like attribute and a p between 0 and 100, the pth percentile xp is a value such that p percentage of the observed values of x are less than xp. It means whenever you have the data, and if you are having like 25, if you want to take like 25 percentage of the data, so the top 25 data will be taken. So you have like 100 data, so the top 25 percentile of the data will be taken, and the median value will be calculated from that 25 percentile. Okay, so that will give you the q1 value. So let me show that. So see, the first quartile denoted as Q1 is the 25th percentile, third quartile is 75th percentile, and median is the 50th percentile. Okay, and the interquartile range is, so
Q3
the
minus Q1.
Q3 minus Q1. Okay, so the interquartile range is like Q3 minus Q1. So we will so using this interquartile range, we can also remove outliers from the data. Okay, so whenever there are outliers in the data, we can remove the outliers using this interquartile range. And box plot clearly defines the outliers in the data. Whenever there is an outliers in the data, the box plot clearly shows the outliers in the data. So what all the box plot shows? So this is the box plot. Okay, so this is the box plot. So this gives the maximum value, and this gives the 75th percentile of the value, and this is the median value, and then this is like 25th percentile of the value, and this is the minimum value. So the box plot, these are the values we will be seeing in the box plot. So the center one, whatever in the box plot, the center one is showing is the median value. So from the median value, if this is the whole box, and if the median value is not in the center, and if it is like moved up or down, then we can say the data is skewed. So the skewness of the data can also be understood from this whisker. Okay, so these are called whiskers. So from the whiskers, we can understand whether the median, okay, the data is skewed or not. Okay, and we can also see the maximum value, minimum value. And if there are outliers in the data, it will be shown as dots, either above maximum or below minimum. Okay, so if there are outliers in the data, it will be shown above maximum value or below minimum value as dots. Okay, I'll show that. Um, so this is the one, right? Let me keep this here. Okay, fine. So yeah, so from the data again, okay, the same tips is being taken. So the tips has been taken and we are just okay giving a box plot for the tips. Okay, so I'll just show this box plot. So see, this is the box plot we have obtained for the tips. Can you tell me like what is there any outliers in the data here?
Yes.
Yes. Okay, so
Yes.
above what point there is an outlier?
Maximum. Above maximum.
Yeah, above maximum, above 6. Okay, whatever data is there, it is considered as the outliers. Okay, so using box plot, using this IQR, okay, we can remove this outliers. Okay, we will see this in the hands-on, but okay, from the box plot we can clearly understand whether there is an outlier in the data or not. Okay, so this is the simple box plot for a attribute which is tip. Okay, so the tip is being shown. So this is the maximum value, which is 6, and this is the minimum value, which is less than 2. So from the description we can see like what is the minimum value. So the minimum value is 1, right? And 25 percentile is 2, 50 is 2, 2.9, and 75 is 3.5. Okay, so that's what here shown. Fine. So 3.5 is okay, Q3, and the median is 2.9, and this is 2. Okay, so this is from the description, whatever describe, okay, the data description, we can clearly understand the box plot values. And if you want to okay, create the box plot for the entire data, that can also be done. So this is for the entire data. So this is for Thursday, Friday, Saturday, and Sunday. So you can see that okay, on Fridays and Sundays there are no outliers. Only on Thursday and Saturday there are some outliers in the data. Okay, so this is for like for all the 4 days. And can you tell me like when, okay, on which day the tip is more?
Sunday.
Yeah, Sunday the tip is more. Okay, the median is also high, and the maximum value is okay above 6. The Sunday the tip is more, and other days okay it is less than 6. Okay, so from this can also be identified. We can plot it for like various fields, and we can understand whether there is an outlier in the data, or okay, which is like a good data or bad. Fine. So I'm stopping here. So if you have any questions, you can ask me now.
Any questions, please?
Yeah. Good evening, madam.
Yeah, yes.
Madam, is in the starting part of the lecture, you said that some signals you have collected, that brain signals.
Yeah, yes.
What is that plot you have used? That you name of the plot?
Scalp. Actually, you have to search as topo plot. TOPOPLOT. Topo plot.
Topo plot.
Yes, topological plot.
It's like one just clarification. Just as per, if the person is hungry,
Mm.
that signals are collected. His brain signals.
Yeah, actually, yeah, the experimental design is like he didn't eat from morning 6 to 11. So after 11, we will be putting the device, EEG device, and we will collect the signals. Okay. So actually, he was not feeling hungry at all. Whenever we collected the data, he was like sitting quietly because it was like 2 minutes, 3 minutes data. He was sitting quietly and he will leave. So we want to like tempt him, so that's why we created the videos. But the first video he didn't react at all, but for the second video, okay, we also collected some prior information like what kind of food he likes. So based on that we created the video. So the second video tempted him. Okay, so that's why we could see the signals in the second one.
Okay, madam. Thank you. It's actually very interesting to hear.
Okay.
Yeah. And one more from this session, outlier is there.
Yes.
Finding outlier. Is there any like detection and elimination methods, standard methods in the implementation point of?
Okay, actually, from the box plot, we will be using that IQR values. So if there are like extreme values, we will be using 3 into IQR values, and then we will remove it. Other than that, I'm not sure like okay how to remove the outliers because I haven't worked on that. So
Because potential applications are there actually. Okay.
okay.
Thank you, madam. Thank you
Yeah.
for your queries.
Any other questions?
Madam,
Yeah. Yes, sir.
uh, same Jupyter notebook will experiment in the hands-on session. So
Mm-hmm.
we need to do the practice with it.
No, I'm not clear with your question. What is it?
Uh, at the time of hands-on is in offline mode.
Mm-hmm.
We will do the experiment with the same notebook that you shared.
Yeah, yes. Yeah, we will be like working on like Jupyter notebook. So okay, before coming, we will let you know like what all need to be installed in your laptop. Otherwise, okay, we will give systems here. We will see like okay how it can be done.
Actually, madam, we are avoiding to bring the laptop. So whether it will available on your machines there.
Okay, sir Vishwanath sir, you can comment on this.
No, we are having desktops here in our lab. Desktops can be used where we can install the Jupyter notebook. It can be installed.
Okay.
Okay, thank you.
So any other questions?
No, ma'am. Thank you.
Yeah, thank you.
So
Thank you.
thank you. If there are no more questions, let me thank the speaker, Dr. Srija, for a wonderful session.
Thank you,
So
ma'am.
thank you, Dr. Srija.
Thank you, sir. Yeah,
So
thank you everyone.
Thank
let
you,
us,
madam.
yeah, let us meet tomorrow. I think slightly the number of participants is improving.
Yes.
I hope that in the coming days we see much better number of participants. Thank you very much. Have a nice day. Good night, all of you.
Thank you, sir. Good night.
Thank you, sir. Good
Yeah,
night.
good
Yes,
night.
sir.
Yeah, good night, ma'am.